Hello friends, सबको नमस्ते. So today in this video we will create a uh, car image segmentation model. Okay, and the model which we use here is with ResNet50 as a backbone. So let me show you the dataset. This is a dataset. Let me show you the classes. How many classes we have? You can see that we have a 5 classes including the background, car, wheel, lights, and window. Okay. So let's get started. We have the images of the cars like this, and we have a mask of them. And you can see that it's a PNG format and images in a it is also in a PNG format, but most of the time, or you can say sometime, the images and the mask extensions are different. So make sure when you train your model, you have to see this. You have to consider this math. Consider this that images and masks, if they have a different extension during preprocessing or during making a data loader, you have to change. You have to make according to that. Okay, so these are the weights of the model, which is to train on 50 epochs, and this is a Jupyter file which I will explain you. This is a helping code which I will explain you when I will explain something something in a code. So let me open this in Jupyter. So this is a so let's get started. So this is a code. This is a, you can see the library which will connect my Google Colab with Google Drive. Suppose you have a data set, copy the link, make sure that it should be tick on this and even with the link, just copy the link and paste it here and keep this part only. You can say this is a unique ID of your data set which help you to connect your or connect not connect, you can say it's download your data set from the Google Drive. So let me run this. Let me first run this. Now run this. See, it first download the zip file from the Google Drive, and now we have to unzip it. See, it's a zip file. See this zip file. And when you unzip it, let me refresh it. Yes, see this. There is a data set with train intent and all these useful files. Now let me run this. This is you can say uh, libraries which help us to create the data loader and to train the model. Okay, and one more thing that this time I am using a Albumentations for the you can say for the data augmentation insist of Torchvision dot transform. Okay, so let me first clear it. uh, Instead of Albumation for the data augmentation, you can also use Torchvision dot transport. It's up to you. Okay, but this time I'm using Albumation. Okay, now let me run this. These are the directories of the train and the images in the mask. Okay, now this will tell me how many number of images and masks is there. It's equal. It has to be equal. Otherwise, it might be possible that mask is present but image is not there, or it might be possible that image is present but mask is not there. So that during training time, it will throw an error. So make sure that number of images and number of masks should be same. Now this is a, you can say this is the thing which I will explain you separately with the help of the help Jupyter code. Okay, you can say this is a the whole code is depend on this part only, how you plot the images with the segmentation. Okay, so let me first run this and see the result. Okay, how the images look with segmentation. See, we have a 4 classes, not 5 classes, including the background. Car will be displayed with red, wheel will be displayed with green, and lights will be displayed with blue, and window will be displayed with yellow. See this. lights blue. This is segmentation. Now how it's happening, how the image is segmenting. Okay, this whole process is dependent this function which I had created manually. Okay, so let me explain you this whole code. Okay, so let me open this is in Zubiquito code. Let me cross it. First thing you have to know that how you retrieve the, or you can say fetch the RGB channel from the image. So let me run this. If suppose I want to retrieve the, or if you can say fetch the arch red channel from the image, I will use the things image, just image, and 0 will represent the red channel, 1 represent the green channel, and 2 represent the blue channel. Now see how this red channel form. See this 25 255 12. How it's come 255 12. 255 320 255 225 3 225 128 64 192 128 64 192, and same way for the green and same way for the blue. Let me show you one thing in how you have to read this. See this. This is the, you can say this whole is a 5 by 5 images, and this is green red part, this is green part, and this is blue part. This way you have to read the red RGB channel from the image. Come back to our explanation. So this is how this is I will explain you how you have to segment the images. See, this is a, you can say this is a mask, or you can say the mask of the image which is in a grayscale format, and this is a overlay. You can see in a code, you can see in a code that I'm using overlay np0s list of size image. Okay, it will create me the overlay array of size image, and all the pixels value in that is 0. Same way I have created it. Now this is the image, suppose this is an image of 3 by 3. Okay, now since in our data set we have a 5 classes including the background, but this time for the easy of explanation I am using just one class with which is represented by this color format. And here alpha is a, you can say 0.5 is a 50% transparency I want, and 50% transparency with the segmentation color. Now see, if suppose any pixel value greater than 0, it should be changed into the 0, it should be changed into 1. See this, in this the mask, you can see in the mask, oh, you can see that 255 is a portion of white, is a portion of white which represent the segmentation part. But during the segmentation, when I do perform a segmentation on the image, I want that 255 is changed into 1 for because it is easy for the calculation, okay, or easy for the identification that particular portion belong to that particular class. That's why I changed that marks all the values greater than 0, it's changed into 1. Now how this thing is performing, let me show you this thing. Okay, this is after mask, after using of the line mask greater than 0 change to 1, this thing performed. After mask I want this is why I changed this, because I already told you that if I will change 255 into 1, it's represent that particular person that belongs to particular class. If suppose 255 is there but it's not representing that particular class, particular area is particular pixel belong to particular class, that's why I changed this. Now before overlay, this is the overlay before using before using these lines, before applying class colors. Okay, class color overlay. Now suppose this class mask, what is happening here, class mask is basically a boolean array, boolean 2D array, which representing me on which portion or on which pixels you have to apply the apply the particular operation or particular changes has to be applied on particular pixel. uh, okay, the size of this is always equal to the mask. See this, class mass is equal to class id, means all the portion mask where the mask is equal to class id, means where in mask or in mask where all the pixel value is equal to 1 will change to true, otherwise all the values where the values is not equal to 1 change to false. Okay, here what is representing a class id? When class color dot item give me two value, see, give me two value. One here, one is representing a class name, class id, and this is representing a class, this two thing. But instead of using, I have used class id, so when I will use it, it changed me into a boolean 2D array, which where the true represent the pixel area where the segmentation had to be applied. Now after this, let me make it scrollable. See this, one more thing I want to explain you. See, it's a 0000. It means its channel. If I want to fetch the red channel, green channel, blue channel from this overlay to the 3D array, it's always will be a 2D array of zero of all the values represent to zero. Means our red region will be zero, zero 2D array, and blue also and green also. But after changing, red channel will look like this, 255 255. You can see that, you can easily see that that 255 representing the true portion, means only change that pixel values where the region has to be segmented. That's why we are using class marks. That's why we are passing till here. You can see that I am iterating per channel. Here is its range is 3 because we have 3 channel. That's why its range is 3. And when the suppose c value is 0, it's give me the red channel, and after getting the red channel, it see that it see only that portion where the boolean is true, because here in class mask, this class mask basically the boolean 2D array. Okay, so it's change only that portion or that area in a overlay red channel where the true is representing. So it's changed that into a, in which it's changed into class color. Now see, and we are using c at 0 na, first iteration. At first iteration c0 at base 255. Now see this, 255 only true portion, 255 255 255. Now second iteration for the green iteration, for fetching, first is fetch the green iteration, check which portion is true. Now now the c value will be 1 for the, you can say 1 for the green channel. So a green channel value will be 255. Again it's change all the values of true into a 255 255 255. Now now for the green channel, the value is 2, value is 3, c means c value will be 2. It says all the value, all it changed the value whether boolean is to boolean to the array is true. Now color at index value 2 is 0, so it will not change any, it will not change a pixel value in this, because already when we fetch the blue channel from the overlay before changes, it's already in a 00 format. And now see how we perform, how do we get a complete overlay. See this, right channel 0 255 255, 0 255 255, 0 0 255, 0 0 255. Okay, 255 0 0 255 0 0, 0 255 0 255 55, and see 0 0 255 0 0 255. This way we form a complete overlay. Now here 255 is a portion where the segmentation has to be performed. Now second important thing is this thing, making a blended image, means changes has to be performed on an image and segment the portion where the classes is there, where the object is present of our class name is. Okay, So how it is performing? See, one thing is important. Let me explain this in a word. Okay, see, this is an overlay. I already explained you how it's formed. Now see this image channels. Image channel, I already explained you in a code how you fetch the image channel. Okay. This is an image channel. This is this array I changes something. Instead of 1 2 3, you can change to 0 0. You will get same image. But one more, but things you have to consider that how you fetch the channels. Now 255 you are green, red channel, green channel, blue channel, red, green, blue channel. This is a overlay channel. This is a image channel. It's now using of this channel we will make a blended image, and we also use a mask here. Now what is the use of here? Mask is equal to 0. Okay, when we are using mask is equal to 0, we actually passing a boolean 2D array, which give us that which give us the boolean array, which boolean array which where the value is 1 in the mask will change to true, other values will change to false. Okay, so here we are actually passing a boolean 2D array. Now how it's making it, let me consider, let C is a, you can see C is a 0 at this time. So in C is 0 means we are fetching a red channel for the image. This is the red channel for the image, you can see that 255 00 255 0 258 128 64 192. Now same for the overlay. Okay, let me make a space here so that you will see that there is two calculation is performing on different two arrays, 2D arrays, 3D arrays, 2D arrays, sorry, this time for the channel, each channel. Same way we are passing here boolean 2D array. Okay, now I already told you what is the use of alpha. Alpha basically gave us that how many transparency we want. Okay, now after fetching the, if C is value 0, we fetch the red channel of the overlay, we fetch the red channel of the image, and when we multiply it with the 1 minus alpha, alpha is value, alpha value is, you can see that alpha value is 0.5. Okay, 0.5. So when we multiply with 0.5 means we are dividing by 2. So 255 divided by 2, 255. See this, it's not changed because at boolean, its value at boolean, this value is false. We do not want to change this value. We cannot change this value. Okay, the value at true is at 1 and 1 only. So 0 divided by 2, no change. 0 divided by 2, no change. Now this here false. Okay, this is 1, means changes has to be performed here, because after make mass is grid 1, at this one portion it is true here. 255 divided by 2, 127.5. 1 is here means true is here. 120 divided by 2, 64. 64 remains same, 192 remains same, because there is at boolean 2D array, which is we are passing here mass is equal to 001. It's actually false here, we don't want to change it. Same for the overlay, class mass is equal to 001. So we will change 255 divided by 2, 127. 255 divided by 2, 127. See, 255 divided by 2, 127. 250 divided by 127. Now what operation we have to perform? Addition operation we have to perform. So please add them. 255 plus 0, 255. 0 plus 127.5, 127.5. 0 plus 127.5, 127.5. See, after adding you will get this. Basically this is a, you can say this is complete, is a red channel of the blended image. Okay, this is a red channel of the blended image. This way you have to get green channel and blue channel. After this you will make this complete array. 255 127 127 25 255 0 255 255 0 255. Same way 0 255 0 255 127 255 295 127 255 127. This way you can make a blended image, and this is the actual image where the segmentation has performed on the objects. Now let me come back to the code. See this. This is a whole code which I have explained you. One thing is different here, that at this time we are passing object marks. We are not using mass is equal to 1. Now I have now I have to explain it here. Okay, so why I'm using a object mask here instead of mask is equal to 1? Because during explanation during explanation, I am using only class 1, means only one class is there. That's why I'm using mask is equal to 1, because only one class is there. But here more than one class is present. But we want changes on car, wheel, lights and window. We do not want changes on background. Means what we have to think, what we have to make that use this object mask is equal to mask not equals to 0. What it means that it will give me true. It means basically after using the function, after using this, its object mask is actually a boolean 2D array which represent that change um, change all the way, not change, it's give me the boolean to the array where the true value basically represent the portions where the segmentation has to be performed, and where there is zero is there. 0 means background, so its value will be boolean value will be false. In short, it's change all the values with the true and false with 0. Okay, this basically represent that uh, portions where all the segmentation has to perform. Now just pass this object mask, okay, as a boolean 2D array which give me a blended image, okay, and change the color according the color which we are giving using this class colors. Okay, this thing. Now let me run it. Now let me explain this. These are the directories. List all the images present in the image directory. Figure basically representing the entire figure. Access here in a 2D format. When we use the array label, it is a 1D format, which is a ease of iteration towards the subplots. We are plotting 16 images. Okay. Figure size will 20 by 18. Alpha I already told you. This is a transparency. Now these are the classes, and these are the class color with the class ID. Now random choice of the image, not random choice from the of the images, means random choice of the image file name. Using that we can create the image path, mask path, and we do not need to change the extension because image path and mask already in a PNG format. Read the image. Okay, now you already know that CB2 read image in BGR format, so we have to change that into a RG format. Now we have to read the image in a grayscale format. 0 basically indicating here is that we are reading the image in a grayscale format. Now why, see this all the performance which we have performed is performed by blended image. See, not blended image, just CB2 add weight function. But I am not using it because when we use it, when I use this function, basically it's change change other portion also where the segmentation do not have to be performed. Okay, okay, that's why I'm now to use this, because it's entirely changed the where the entirely change the values. Let me show this. Suppose if I use the that function CB2 add weights, it's changed 255 also, 0 also, uh, uh, 255 0, not 255 and 0 also. Okay, 0 also, because it does not because it's does not because it's not using a boolean class, boolean 2D array which we are giving passing during the manual change. Okay, so this is the difference, that if you does not want that your background will change, or you can say dullness will occur in your image, you can change them or change or segment the image manually. Okay, so this is a function which we are passing the image mask and class blended image. Now let me show you the difference. Let me use this blended image, overlay is not here. Let me show you the difference of this. See, it's give me dull images. Okay, you will get confused that why the segmentation is not performed. So for the segmentation, you have to change the overlay. Okay, so let me use this also. Then you will see the proper result, that why I'm converting the things manually instead of using the function. Okay, now let me run this. See, there is a dullness in the background. See, there is a dullness in the background. See this, there is a dullness in the background. But when I convert this whole thing into manually using the function which I had created, see the result. You will see that there is not any dullness in the background. Now let me run this. See, there is not no dullness in the background. That's why manually creating the blended image, because when I will use a function, it make the background dull, which I do not want that. That's why. Now come back to the so this is a class name. This is a torch.coda which give me the thing that which we are using GPU or a CPU. Now we are using FCN ResNet50. FCN is fully convolutional network. ResNet50 has the background. We want pre-trained with to model the classifier for. Let me print the model here for better explanation for you. See, we are having two classifier. One is this, and one is auxiliary classifier. But during training, I don't want this auxiliary classifier, so that's why I make it none in the initialization of the model or auxiliary classifier none. And see, go to the model, go to the classifier, go to the fourth layer of that, and change that. 512 length means what is will be the output channel is depend on the class names which we have. Kernel size will be 1 by 1. So see, we go to the model, go to the classifier, and go to the fourth layer, change this according to the number of classes which we have. See, 21 is basically is pre-trained, so that's why it's 21 representing the number of classes which is trained on the trained which is trained by model. Okay, so this is the model which we are using, FCN ResNet50 for the segmentation, which is and model 2 is 2 device. Now come back to our code. Now this is a class car segmentation dataset. Okay, this is a dataset which we are using. Some of the functions which is present in a dataset we can use. Okay, now this is the initialization of the variables. We are just giving the image directory, marks directory, and transform. And transformation basically the augmentation if it is needed in a images. But this time we use transform because the number of images for the train part is less. So we have to add the data augmentation for that. Now initialize them, initial image directory, marks directory, image file name and marks file name, just sorted OS listers image directly. It keep the number of name of the images present in a particular directory. Salver transform. This is a class label. Number of images present in that particular directory or number of images present in that. Now IDX basically here is used for fetching the file name or the image name from the directory. Okay, so self that file, just first we have to create the image path, west part join, self the image directory, just pass the image directory, solve the self dot image file names. Okay, just give the IDs is fetch the particular index directory or index file name in particular directory. Now we have to read the image, and already know that CB to read the image in BGR format, so we have to convert it in RGB. Now read the image in a grayscale format. Instead of this CVD ambient grayscale, you can use 0 also. Now what is the meaning of this? Mask is equal to np clip mask is equal to 0 length class labels and -1 as step np to do. Okay, so let me explain this line with the help. Suppose this is a mask, okay, and it's contain the values which is does not match with 0, 1, 2, 3, 4, because in mask the value should be in the limit in the range of 0 to 4th, means number of the length of the number of classes which we have. It should be range between 0 and length of the number of classes. It should not be go beyond that, because mask if suppose the values go beyond that, it's you can say this is irrelevant pixel or unnecessary pixel, you can say. So for that, here the values is 6 is unnecessary, 1 is necessary. When you use np clip mask 0, means in the range in mask should be from start with 0 and end with length of class -1. Okay, it's convert that, after that it's converted into unit unit. So let me print it, let me run this cell. See, its values is changed, 6 changed to 4, 3 remains same, -1 is changed to 0. This way it's used because we do not want the uh, pixels values which is not in a range of 0 to length of the class level, length of the class levels. Okay, now if we are using an data augmentation transform, we have to use that into our images and the mask both. So just put the augment self to transport images and mask. Okay, and it will give me, and use this augmented images and mask, it will give me image and mask, and after that return the image, and the mask data type should be long. Now run it. See, this is the, you can say this is the data augmentation which I am using. Resizing of image into vertical, horizontal, color filter, color not color filter, color jitter. Shift scale row normalization is there to tensor, converting the image into tensor format. These are the directories. Now we have to first create the train data set object of the class which we have created. Now pass the according to constructor, according to our init function, pass the parameters, image directory, image mask, transform. Okay. Now, after using a data loader library, we can create the data loaders, train data pass, just pass our object. Now, batch size we want is 8. Shuffle will be there, means shuffling of the images will be performed. Now, the loss which we are using is cross entropy loss, and optimizer we are using add an optimizer with the learning rate will be 0.001. Okay, let me run it. Okay, now this is a best loss, means I want to train this model. I do not have a mod images for the validation, so just we have to train that model. Best loss will be infinite. Save path will be, or save path will be more best model list, and I will train this to 2 epoch only, because I already trained this model on 50 epoch and download that weights. When it come for the speed of this, for the explanation, I'm training this to the 2 epoch. Now just iterate over the epochs. Model.train basically give the definition that a particular model is now in a training mode and updation of the weights has to be performed here. Now iterate over the train loader. Images and mask should be on a same device which is on the model is. Okay. Optimizer zero grade. What is the use of optimizer zero grade? Means it's change the gradient value to 0, which is helpful in the updation of the weights. Now why we use this line during the batch iteration? Because if suppose we do not use it, the value of the previous gradient value will get accumulated to a current gradient value, and the updation of the weights get affected. That's why we use optimizer zero grade. Now fetch the output. Now pass the output in a mask. In a criterion loss, we'll get the loss. Loss dot backward basically calculate the weights value. Just calculate the weights value. Updation of the weights is not performed here. Optimize the zero steps step will update the value. Now losses of the item will store in epoch loss. And see, we are multiplying with train loader average epoch log. Now just print them. If suppose the epoch loss is less than the best loss, just change the best loss and save that model. Now let me run it just for the two epoch. Before that, let me explain you this whole thing. What is it has to be performed during testing. So this is a device, this is a class names. Just load the model. Pretrain false, because we don't want a model to be we are not using a pretrain model here. Just false will be there, because during testing time we use just a model and we load the weights. Okay, we do not want a pre-trained weights. We can load our weight after. We just want a structure of the model. We do not want any weights there. Okay, that's why pre-trained will be false. Same thing, none model auxiliary classifier false, none. And same thing, length of the class is kernel 001. Now we have to load the model. Now model.stake.tick load, it will load the model. Model is to device. Evaluation mode means no operation has to perform the weights. Test directory basically contain the images for the testing part. This is a subplots. We are plotting 16 images, 50% transparency. These are the class labels, class colors. Okay. Now we are adding the, you can say, data augmentation, but three things is important: and normalization and resize and converting the image into a tensor format. Okay. Now read the image from the image path. It will image path how it is selected. We randomly choose the image file name from the images variable. Now using that we create the image path name. Now we have to read the image and convert it into our RGB format. We apply transform augmentation. Now after that we will add one batch dimension in the image using the unsqueeze 0. After that we are passing the image to our device. Now torch.noGrid means no operation of the weights has to perform here. Now we have to pass the images and fetch the output, or you can say the mask, from the model. Torch.argument.output dimension 0 CPU numpy. Basically this line give me the predicted mask from the output which is predicted by the model. Now we want mask which is predicted by the model has to be on a same shape and height, same width and height that the particular original image is there. Okay, so that's why pass the predict mask image shape 1 and image shape 0. Image shape 1 will give me the width and height of the image. Interpolation means filling the pixels value which is not defined. Okay, we can fill them with the enter nearest pixel means empty pixels value will be filled with the nearest pixel values. Just pass the mask image class colors alpha in the function which I already explained above in the code. So now let me run it. Now let me first upload the model which is trained on 50 epoch. Okay, let me first pause this video, then I will come back. So friend, this is a weight file which is trained on 50 epochs. Okay, I already changed the model path. Now let me run it so we can see the result of unseen dataset, how it model performing on unseen dataset. You can see the result. Somewhere it's working fine, somewhere it's working not that much good, but we can see that our model is working 70 to 80% good in the place of segmentation. Okay, so this is over. You can now this my model is trained on 50 epoch. Now you can change make modification on data augmentation, or either you can increase the data set, or either you can change the epoch value, or either you can change the learning rate value for increasing the accuracy. Okay, so this is over. Please like, share, and subscribe, because I explain you everything in detail. This whole part, this function, I explain you in detail, because it's necessary for you to explain how the segmentation is performing on images. Okay, how mask and image is used for the segmentation. I explain this part very clearly for to you. Okay, please like, share, and subscribe to get more videos like this, where I will explain you each thing in detail way. Thank you.